Today we're going to be talking about the first part of our function operations. Today we are focusing in on addition, subtraction, multiplication, and division. So when we're working through these, you'll be given two functions and you'll be expected to do some type of operation with it. And the two different ways I typically write it is either with parentheses telling the two function names, which is the f and the g, and then the operation between it, or they'll list them separately as functions and tell you the operation between it. So look for one of those two methods of getting you that information. So on this problem, we are going to be adding. And so we're going to take our f function and add our g function to it. So f plus g of x, and all this x is tells us what our variable is going to be, or if we're going to substitute in a number. Sometimes we'll substitute a number in for all our variables. So we're going to write our f of x function, 2x squared minus x plus 7, our operation, which was addition. I recommend always putting your second one in parentheses, just in case you have to distribute anything. Plus 6x minus 1. When we distribute that positive sign through to both parts, it's not going to change anything. So I'm just going to rewrite it without the parentheses. As we distribute that positive sign through, it keeps all the signs in the same direction. Now we're going to look at combining like terms. So let's look at our x squareds. We're going to combine our x squared. So I have 2x squared plus x squared, and that gives me 3x squared. And then I'm going to combine my x's. So a negative x, so negative 1x plus 6x is going to be a positive 5x. And the last one I'm going to combine is my constants. Positive 7 plus a negative 1 gives me a positive 6. And so this is my final answer. So f plus g of x is 3x squared plus 5x plus 6. And as long as there is no division, means there's no variables in the denominator, for today's, when we're doing these, our domain, because it's going to ask you for your domain, is all real numbers. And just kind of a refresher, remember when we talked about this yesterday with the interval notation, that was a negative infinity to positive infinity. So either way they may ask for it. It's either all real numbers or negative infinity to positive infinity. Let's go on to our next one. So this next one, we are going to subtract two functions. And so it's going to be the same idea. We have f minus g. And so we're going to take the f function and that tells us we're going to plug in an x. So we have 2x squared minus x plus 7. And then we are going to subtract the g function. And again, like I said before, put the second one in parentheses, especially when you have a subtraction. It helps you keep signs in order. And so when I distribute that negative sign through, when I rewrite it, we have the f minus g of x. Nothing changed on that first bit. When I distribute that minus sign through, though, it becomes negative x squared minus 6x plus 1. And then we're going to look at combining like terms. So x squareds combine, giving me a x squared. I take my x's, a minus x and a minus 6x. That gives me a minus 7x. And then I take my constants, positive 7 and positive 1. That gives me plus 8. And so f minus g of x is equal to x squared minus 7x plus 8. And the domain, we don't have a denominator, so that means that we have all reals or from negative infinity to positive infinity. This next problem, we're going to be multiplying. And so I'm going to take the f function and multiply it to the g function. So f times g of x. And so we have 3x squared minus 1. And then we have, on the second parenthesis, we have x squared minus 4x minus 5. And so what I'm going to do is take each of those terms and multiply it through. So I'm going to take that 3x squared and I will multiply it to each of the pieces. And so 3x squared times x squared gives me 3x to the 4th. Because x squared times x squared is x to the 4th. 3 times 1 is 3. 3x squared times negative 4x gives me a negative 12x. We have 2 here, 1 here, so x cubed. 3x squared times negative 5 gives me a negative 15x squared. And then I'm going to take and use my second set. So I'm going to take this negative 1 and distribute it through. So negative 1 times x squared gives me negative x squared. Negative 1 times x, negative 4x is going to give me a positive 4x. And negative 1 times negative 5 gives me a positive 5. And then I need to combine like terms. Well, the only thing that I have that's in common is I have these x squareds in common. And so everything else just gets copied down as is. And then those we combine. Negative 15 minus 1 gives me negative 16x squared plus 4x plus 5. So that f times g of x is 3x to the 4th minus 12x cubed minus 16x squared plus 4x plus 5. And my domain is all reals, because there's nothing in the denominator, or from negative infinity to positive infinity. One last type that we'll be dealing with is going to be your division. And so when we're dividing, these are some of the simplest ones. So right now, the only thing, we will go into these a little bit deeper further into this year. But right now, all I'm going to be expecting is when you divide, you're going to write it as a fraction. F divided by x minus f of x divided by g of x. And when we do that, the only thing that we have to worry about is now our domain is not all reals. It's all reals except for certain things. So we say x can't equal certain areas. And what it can't equal is what's in the denominator. So you set the denominator equal to 0. X minus 5 is equal to 0. And then you're also going to set x plus 1 equal to 0. Because those are the two things it can't be. So it's when it's not 5 and when it's not -1. So the domain is x can't equal 5 or x can't equal -1.